we were talking about, let me even change it, the total surface area, just surface area. So let me even change this part here. Okay, so here we're talking about the total surface area. Didn't allow me to put a space, but anyway, hope you get it. So it's the total surface area. Total surface area. They have to be space there, but my keyboard won't allow me to do that. Okay, so the total surface area of a cylinder. This is what we were doing. We're finding the total surface area of a cylinder. So this should have been the total surface area. But going back to our question, so the formula for total surface area is this one. This is how you find the total surface area. But if you want to find the curved surface area, you only use this one here. That is for the curved surface area. You don't include these two circles. So this question here wants us to find the curved surface area of the cylinder. So guess what formula do we use? So we use that formula to find. So okay, if this is the curved surface area, if I were to cut this this curved part and then straighten it, it will make something like a rectangle. You can do better than that, I think. Okay, if you were to, it will make something like a rectangular shape. Okay, something like that. So it will make something like this, and we know that the height is h, which is 9 centimeters. From here it's the same, so this will be 9 centimeters. 9 centimeters, and then which is wobbly 9, but anyway it's 9 centimeters. And we know this part here is not 7. This is the diameter. This is from here up to there. Now we want to find the circular length, which is the circumference of that circle. So now some might be asking, but you said we shouldn't use the circular part. Yes, what meant is we are not going to find the surface area for this circular part. We're using its diameter. We're using the diameter, that is this distance around the circle, which is totally different from the total surface area of a circle. The surface area, it is this blue part here, which is different from this line which goes around the circle, which is called the circumference. Okay, so we're not going to use this area, the area. We're just going to use this distance around the circle, which is the circumference. Okay, so for you to get the circumference around the circle, you need the radius. And here you might make a mistake of just using the diameter. That'll be wrong. Diameter is twice the radius, so you have to find half of the diameter for you to get what the radius is. So the radius here will be 3.5. Half of 7, that is 7 divided by 2, you get 3.5. So the radius is 3.5. That is for the radius. So if our radius for this circle is 3.5, so you can find the circumference would be 2 times pi, which is 22 over 7, times the radius, which is 3.5. Here we'll just say 2 times pi, we know what pi is, times the radius, which is 3.5. 3.5. So when you multiply this, 2 times pi times 3.5, let's see what we get. So we have the circumference. So why do we need the circumference? Because this circumference is this distance from here to there. That is the distance we're looking for. If we get this distance, then we can multiply this distance times this height here to get the curved surface area. So no wonder we need the circumference, because it is our length. So we are using the diameter to get the radius, and then using the radius to get the circumference, which is our length. Hope that is clear enough. So let's 2 times pi times 3.5 on our calculator. What do we get? Alright, since this is paper 1, we don't have to use a calculator. So we say 3.5 this could be 2 times 22 over 7 times 3.5. So we say 7 there is 1, 7 to 3.5 is 0.5. Okay, 7 to 35, it's 5 times. Now we are adding a point there because this is 3.5. So 0.5 times 2, we get that is 1. 1 times 22, that is 22. That is 22. So we got our length, which is 22 centimeters, which is our circumference. So if you multiply 22 by 9, what do we get? That is 819 there, which is 198. Okay, so we get 198 centimeters. So the curved surface area is going to be 198 centimeters cubed. This is the area, so we use centimeters squared. Did I say cubed? Centimeters squared, not cubed. Centimeters squared. Hope I don't know if I said that. So it's 198 centimeters squared. Okay, so this is the surface area of a cylinder. Guess we're running out of time, so we'll end here, and we'll talk more on how to find other mensuration problems probably in the next lecture. For now, we will end here, and we'll have a an exercise on how to do this. So see you in the next lesson. Okay, just one part. So I wanted to end there, but the spirits of the ancestors have just said, no, we gotta do something else. Okay, so the diagram below shows I couldn't get a much clearer question for this one. I'm sorry. That is for the GCSE PastPaper 2020 Mathematics ECZ question 11. I couldn't find a much clearer paper. So question. So just read it out for you if you can barely see it. The diagram below shows a right square pyramid of base 6 centimeters and EF is 5 centimeters. So the question says, calculate the total surface area of the triangular faces. Calculate the total surface area of the triangular faces. That is this face, that face. How many triangular faces does this one have? 1 here, 2, then there's okay, so we have 1 triangular face, 2, the third one, and the fourth one there. So there are 4. So the question says find the total surface area of the triangular faces. So what do? We said in the previous lecture that you just find the surface area of each face and then add them together. Now this one, we won't include this square base. We just want a triangular faces. That is what the question is saying. And you know how to find the area of a triangle. For this one, you know that we can use the formula now to find the area of a triangle, can't we? Okay, we can. And then they've showed us that this from here to the base, the EF, which is distance from there to there, is 5 centimeters. And then we know that it's a perpendicular bisector because of this one. It's a right angle triangle. So we can use for this one, we've got 2 of them, but we can use for one, we can use surface area is equals to half BH. When you use this formula, we're going to find surface area for one triangle here, and then we multiply by 2 to find the total surface area for one face. And then we can do that by multiplying by 1, 2, 3, 4. That will be total surface area of the bases. Okay, so we should be area is equals to 1 over 2 times the base from here to there is 6 centimeters, but we only going to use here a to f, which is half of 6, which is 3. Don't know why I'm having problems writing 3 times the height from here to there. It is 5 centimeters. So which gives us the area as 7.5. So 7.5 is the area for this part here, from here, this triangle here. Now we know that there are 2 of these because there's this other side as well. It's like you mirror this side onto the other one, so we just have to multiply by 2. So we can multiply this by 2, and then 7.5 times 2 give us 15. So the area is going to be 15 centimeters cubed for one face. Now that is for one face here, but we know we have, how many faces do we have? 1, 2, 3, 4 of them, so we just have to multiply this by 4, and the total surface area for the triangular faces is going to be 15 by 4. We know 15 times 2, that is 30, and by 2 that gives us 60. So this is 60 centimeters cubed as the surface area for the triangular faces. Okay, so the question said find the total surface area for the triangular faces. So this is how we do it. Okay, all right, so we can end here.